Trust me, we can always talk more.
I don't know if you want us to keep talking.
You are
At least 20 minutes because I actually have a lot to get.
You are live on the internet.
All right. Hello, everyone. Thank you so much for coming. I see a lot of you are also at the workshops. Are you having fun at the workshops? You think you're good? Yeah. Okay. Cool. Yeah, we're getting like really good attendance on them. So it's really good. Like 35 people at the other one. It's insane. So just like always, I have a few announcements for you. The first is I just want to say, thank you. It's going to be like a great CTF, or at least we have the money to make a great CTF, because all of these people have volunteered to sponsor us, and that's round of applause. And I think we should cap it there because I don't want to end up with too much money. But yeah, thank you.
No, that's never a problem.
Yeah.
Wait, so our shirt's gonna be made?
Oh yeah,
Yes.
like easily with
I'll show up then.
We have like $4,200 or something.
Jesus.
So really good news. Security Compass was the last to email me this morning. Okay, so next announcement is this thing, which is the Threat Defense Challenge. If you guys were on general, somebody posted about it. It looks pretty cool. It seems like it's like a workshop. Trend Micro's hosting it, and essentially it's you start first in like the blue team role, and then you move to sort of the red team role. So first you're like defending systems, and then you're attacking systems, and they just kind of walk you through the entire life cycle. It's on November 20th, 2019. So if you have some time, it's totally free. 9 to 3. And then just so you know, so we also have on the 23rd, right? Yeah, the 23rd from 9:30 to 5:30, we have our Intro to Red Teaming workshops. It's going to be led by Mr. Benjamin Maher, who's the Director of Advisory at Security Compass. So I now have the slides and I have all the material. So we're going to open 40 seats for it. I'm only going to reserve 8 though for first years because the content is quite involved. And it's not that the tools are hard, like you're going to be using Metasploit and Nmap, which are really easy to learn, you can learn them in a bunch of YouTube videos, and I would definitely recommend that. But the underlying concepts can be quite difficult. You need to have a lot of multidisciplinary knowledge. But again, I didn't want to restrict you for the first years because I want you to see what it's like. But again, I'm sort of compromising there by only giving you 8 spots. Okay, I hope that's okay. I hope you don't hate me. Jen.
There's one person that wants to come, probably. Nobody takes it seriously. Anyways.
Yeah, and then we'll be releasing the tickets on Eventbrite at 11:30, and we'll make a post about it just so you know exactly all the details about that.
This coming Monday?
Okay.
Yeah.
Yes, this coming Monday, and then the workshops on the Saturday. Sweet. Yeah. And one more announcement. You should do a talk. So we are starting to build the schedule for next semester. So if you're interested in doing the talk, please let me know, or any of the people there. Forgot to edit out the looking for speakers part. But yeah, anyway. So yeah, that's it for me. And on to the news roundup with Nick and I.
All right. Cool. So you're going to notice that the first few stories are all kind of on a theme or on a topic. It was like the week or 2 weeks of security vulnerabilities or statements or issues related basically to CPU architecture or very, very low level stuff. Either being vulnerabilities being exploited or not patched and stuff like that. Lots of research coming out. Because since last year's or earlier in the year's discovery of issues like Spectre and Meltdown and stuff like that, researching how CPUs execute code and if there are vulnerabilities in that has become a really hot research area. So obviously stuff's going to start coming out quickly, and we're probably going to see a lot of it, I would guess, over the next few years. Whenever an area like that starts to bubble up as a new research area, loads of people dive on it, and you get this big burst of research in that area specifically. So the first one, TPM failed. Modern computing infrastructure has these things called trusted platform modules. where like secure data can be stored in a machine. Imagine stuff like the iPhone's secure enclave, which in the iPhone, it's actually a separate physical chip that can store really, really sensitive data in an encrypted way that's next to impossible to get off of the silicon, even if you have like access to the physical hardware. You need to provide it with the correct password or you're not getting anything out of it. These things can exist in a software form as well, but like really low down in the hardware stack, in the technology.
Well, they're perceived to be more secure if they're doing it through hardware instead of software.
Yeah, exactly.
It just doesn't make it very flexible after the fact.
Correct. So these things operate at a very low level. You need like machine level permissions, like beyond root. You need like a lot of credentials and power to access and to manipulate these things. However, so this first article, a group of researchers discovered that there's what they call a timing attack in the trusted platform module for a number of chips. I think they're Intel's, but I think they demonstrated it on a couple of different platforms. The idea is that I can send a sequence of instructions to some CPU, right, and I can time how long it takes to get back to me, right? And the changes in the time it takes to do some of those instructions let me know some of the data that it might be operating on. So for example, I say, here's some data, I want you to decrypt this. The amount of time it takes to decrypt, if I do that many, many, many times, can actually let me infer what the decryption key stored in that trusted platform module is. Because, if it takes 1 millisecond to decrypt something when the letter or the number in the key is a 5, and then the next time it might take like 2 milliseconds if the number in the key is like an 8 or something like that. And with enough trial and error and with enough data thrown at it, I can derive this key. So it can take, like it says here, it can take minutes to hours. Hours being if I'm actually using this attack on some like VPN service, right? And I'm sending requests to their web server. I can eventually figure out what the VPN's encryption keys are based on the amount of time it takes to get back. Now I have to do lots and lots and lots of requests to be able to figure this out because of things like network latency. We have to analyze all that statistically and filter out all that data. But eventually, we can figure out things like a remote services decryption key, and that's terrifying.
And in that situation, it's very hard to be able to detect it because it looks like normal behavior. It's just someone trying to authenticate with a VPN server. That's kind of normal traffic.
Totally.
Right?
So, really interesting that like a CPU issue, like a timing issue, is something that we can detect and exploit from the other side of the internet. Like that's just, I find that wild personally, because even like minor network latency. Talk about that.
So that was the VPN.
This is the second story on this.
Yeah. So just building off of that. So in regards to the VPN. So basically it's timing. So in this case, there are multiple universities that were involved in this. So University of California, University of Lübeck, and I believe it was another German Polytechnic Institute. Side channel. So they basically locally they can exploit this in about 4 minutes to 20 minutes, and then remotely it takes them about 5 hours. But like Nick said, you're able to get the shared secret, and so you're able to impersonate the VPN. You're able to decrypt people's traffic that are connecting to your VPN, or capturing the traffic being sent to the VPN, then being able to decrypt it on the side. So it's pretty tough to detect. So
Interesting. Another one that got kind of released or disclosed like yesterday, I think. It's called Zombie Load. This is a different style of attack. So this is not a timing attack, but it's still an attack related to how CPUs work. Similar to Spectre and Meltdown, which rely on the fact that our CPUs try to actually think of it as pre-calculate or pre-compute a bunch of data for a program based on how the CPU thinks the program's going to run, right? And the original Spectre and Meltdown vulnerabilities took advantage of that fact. This is a similar attack where basically people have figured out that I can still exploit what they call that speculative execution, and rather than reading specific data, I can still take samples of data from what that speculative execution is calculating. The idea is that when it goes through those speculative branches, it's not sure what data it's going to have to operate on, so it'll just like take some data, sometimes like just random data from that program's area of memory it's allowed to read from. and an adjacent or another process on the same CPU core can actually see what data is being operated on and take like little copies of it. So you might not get anything useful from this attack. The idea is I'm just getting like random samples of data. So if I do this enough, I might get something useful. Sometimes I might just get garbage that's totally not relevant. But the idea is that it could be important. So it's not as critical as like Meltdown Inspector and stuff, but it's still potentially
It's
an
worth
issue.
noting that this is speculative execution, so it means that the processor, when you click on a button, it's not really executing in real time. It's already pre-calculated, so it tries guessing what the user does. So that's why there's that speculation branches. So it'll calculate different possibilities so that things are very fast. So things when someone clicks a button, that logic is already executed partially.
Cool. They have a nice FAQ too if you want to learn more. My personal favorite was, has this been executed in the wild? We don't know. I love that. We're not sure.
Yep.
This one's
Okay. So yeah, so the Intel flaw. So again, researchers from multiple universities. So this one used rogue data in flight data loading. So, or as Intel likes to call it, microarchitecture data sampling. So basically, this vulnerability allows a hacker to run code on the victim's machine, and it will leak sensitive data. So all it requires is like running JavaScript in a browser, or the really dangerous one, which is virtual machines running in the cloud. So cloud environment has become very popular, especially for enterprises. So that's a really big danger. And so yeah, except this article also touches on the fact that they're kind of disappointed with Intel's slow response to addressing the issues and not addressing the root causes, but kind of addressing specific use cases. So yeah, it's kind of some of these mitigations just require the CPU running slower. And yeah, that's especially since AMD and Intel are kind of index in regards to performance. It's kind of hard to justify.
That's a fantastic lead into this graphic.
Oh,
So
yeah.
to kind of sum up these articles where basically there are problems in current CPUs. Yes, you can either apply a patch or you can slow down the CPU or you can wait for the next generation of CPUs that rather than having a patch actually fixes it in hardware, so hopefully you don't have performance hits. So some people did a study and this is a chart from that study. Don't worry if you can't actually read the values, all you got to see is the colors. Where basically they're talking about various issues that have come up, and then like either at CPU level or in kernel code as well, and then patches that have been applied to those vulnerabilities in Linux, and then performance degradation over time after those patches have been applied. And what's really interesting, so like red means slow, green means fast in terms of CPU performance. What's really interesting is if you look in the middle here, it seems that for a while, like from version 3 of the Linux kernel up to 4.14-ish, they were making improvements. Like look at all the green right in the middle here, right? That meant that the Linux kernel was getting faster because they were writing better code. But then look at right around the time that the patches for Spectre and Meltdown and some of these other CPU-related issues, those patches get released. Linux obviously has to patch the Linux kernel to safeguard against these things. Now look what happened around the same time in terms of performance. We dropped off down into that red area, meaning, yeah, you can apply these patches, but there are significant performance impacts to computing because of it. Because that whole concept of things like speculative execution, where the CPU guesses what it's going to run next and it pre-does it for you, that actually does make computers really, really fast. Turns out it also makes them insecure, but it makes them really fast. So I'm glad that we actually have some data around this. And it'll be interesting to see how this evolves as the next generation of CPUs come out that hopefully have this stuff fixed in hardware and don't require kernel level patches for it.
And this only makes it more difficult, like I said, with companies shifting to the cloud, is everyone's data, or you don't know whose VM is running next to yours on the same machine. You don't know. It's just abstracted completely. So like you need to like cloud providers really need to patch this. Like when Spectre Meltdown came out, I think the cloud providers got heads up, I think beforehand or something like that.
At the same time, it's also brutal because then
yeah, because
performance.
they're charging by like the second, right?
Yeah.
So
some of them,
yeah. We already have some contracts
Yep.
and stuff. So.
In a similar vein to that stuff, people were viewing software development kits or SDKs for talking to some of these secure enclaves and trusted computing modules, and they found that even in the tools that are written to talk to this stuff, holy crap, there's a lot of software vulnerabilities. We can't get away from that problem. I mean, humans write code. Humans are fallible, therefore code they write will be fallible. It's just worth pointing out that in addition to the problems in the actual silicon, we also have problems in the software that talks to the silicon. Not great.
There's a statistic. It's like for every line of code, there's like a certain amount of vulnerabilities. So even if you patch a bug and you introduce new code, you're just introducing more bugs in different ways. It's a bit of a...
What Adam's referring to is there was a really cool book called The Mythical Man Month that was written by Fred Brooks Jr. about software engineering. And in the book, one of his discoveries was that there actually is a ratio to lines of code and bugs per lines of code. And then in security, we extend that to say, and for every bug, there's a certain likelihood that that bug is actually a security issue. Mm-hmm. So basically you could boil it down to there's a certain ratio of security issues per lines of code.
And it comes into play, like the OpenSSH, there was a sort of vulnerability that happened where they can sort of guess someone's username but not password. Mm-hmm. So they can kind of determine if it's a valid user, and then like the OpenSSH community developers were like, we're not patching this because we don't know, as bad as it is, if we change the fundamental design, it may introduce even worse vulnerabilities. Yes. So we're just going to deal with it.
Irreducible number of bugs.
Exactly. Yeah. So,
This one was awesome. So a company was breached, and they even found out they were breached until one of their servers started saying, yo, my hard drives are full, because bad guy was using that server to stage all the data to then exfiltrate it and steal it. That's how they found out. And I don't even care about the details of this. You can go and read. It's a trade. Yeah. Oh yeah, they were not doing security well, but there was this company called Infotrax. Trade and funds and stuff. Infotrax.
So finance? Oh, awesome.
Whatever. Just ignoring all that though, just the fact that was their indicator of compromise. Why is our hard drive full? Oh, there's a giant zip file here that says stolen data. That's amazing. I love it. You never know what's going to tip you off, right? To do your incident response.
That one hacker that got caught.
Yeah, dude. What happened to doing things in batches? I don't know.
Yeah.
Anyway.
Oh man. Get their data deleted.
Yeah, that's true. Yeah. At least they have it all in one nice spot now too.
Yeah.
Someone posted this in our Discord channel. I think it was Press OK, who I don't think is here this evening. But anyways, they found this article on Wired, and this is super cool. So some researchers discovered that you can use a really high-powered laser pointer, not the kind that you play with your cat with, one of the ones that's actually going to burn your eyeball out. And from a reasonable distance, you can aim and fire these things at the speaker module in something like an Amazon Echo or a Google Home or whatever, because really, the beam of light that you're projecting, if it's a high enough powered laser pointer, really you're just beaming energy, right? Which is the same thing as a sound wave. So regardless of the type of energy, if it hits a microphone that's sensitive enough, the microphone will register receiving that signal. So if we flash the laser pointer in the right sequence and in the right way with the right, frequencies and all that junk, we can mimic human speech, or at least a waveform that will look like human speech, although it's probably in a different frequency or tone or whatever. Yeah, thank you. So they basically proved that with a laser pointer, they could talk to one of these boxes if you basically have a line of sight to the microphone module. They demonstrated it actually at a conference in a really cool way by having somebody wear earphones, and they basically hooked up the microphone from the unit, the smart home unit, to the earbuds or to the headphones or whatever, and they were flashing the light at it, and the person said, yeah, I can actually hear when the light hits the microphone. That's cool. Also, so don't put your Amazon Home line of sight from window, or just turn the microphone so it's facing into your house or something. That's cool though. That's neat.
Yep.
Oh my goodness, cell phones come with bloatware, especially especially really cheap phones. But even then, it's not even the expensive ones have third-party issues. But anyways, so a survey found that 146 phones come pre-installed on the average. Not top tier, but sketchy Android phone. Not great. And mostly they attribute this to the fact that these days, just selling hardware doesn't make people money.
right? To help recover additional costs, companies will basically get paid from software vendors to preload software on their phones, right? So for example, you buy like a new Samsung Android phone and it's going to come with a bunch of third-party apps already installed on it. Well, they've been paid to put that there, right? Or you buy a laptop. Comes with a bunch of stuff on it. Yeah, exactly. Comes with some antivirus suite or whatever. The manufacturer has been paid to put that on there to help recover or make additional money. And it turns out that, yeah, there's a lot of vulnerable apps that get pushed onto Android phones. The other challenging part is that even like a top shelf or like a well-branded Android phone is still going to have, you know, like features that third parties can pay to maybe tap into or to integrate with. So even a good phone might indirectly have some like what we call supply chain vulnerabilities and issues in them. That sucks. They honestly, if we're going to continue down this path, we need to do something about cleaning up the the zoo in the App Store or the Google Play Store.
I remember back in the day when I bought like the $100 tablet from AliExpress, came rooted.
Nice.
Nice. We've evolved, I guess, from rooted tablets to just bloatware that's.
That's probably also malware.
Yeah.
Awesome.
Oh yeah, so this is just kind of an informational thing. So basically, like it's just kind of like I think this author, he went through and he like tried, you know how you can like unsubscribe from like call lists and whatnot. So he kind of covered how you can do that. How you can do that online. So basically, like he just kind of spoke. A lot of these services pull like data brokers, collect public records from online sources, and kind of it's a lot of value. It's very valuable, and these data brokers will then sell it to like marketers and whatnot. So it kind of going through that, and then kind of giving tips. So, for example. So yeah, it's saying like getting delisted is hard because you have to go to each individual data broker, or you can pay for a service, but like these services don't come cheap. Like I think one is like almost $500, another one, yeah, like Privacy Duck is like $500.
Damn.
Yeah, it's a lot. So it'll be for like the CEOs and whatnot, like public figures probably, but not for like everyday type people. And like saying like, you know, like if you're not planning to open up like credit accounts, like to prevent identity theft, like freeze your account, like freeze your credit score if you can. So yeah, like it's getting harder to do it, but it is possible. Some sites are better, some sites are easier, and it just kind of walks you through a process of what he did. So yeah. So
like be careful about what you put online because it's really hard to take down.
Well, actually, the interesting part that he mentioned was that they collect a lot of this data from public records anyways. They just scrape it. So, yeah. This one is also mine. So, yeah, NVIDIA got hit with, there were some CVEs that were attached to NVIDIA products, several NVIDIA products, so they can lead to escalation of privilege, DDoS, and other nasty things. So, NVIDIA released a patch to 2 of their products, so the NVIDIA GPU driver and GeForce Experience. So the NVIDIA driver had 3 high-severity CVEs attached, and they were related to the kernel module. It's hard to write a driver. It's hard to find people that know how to write low-level drivers. So, yeah, basically the issues stem from not validating the size of input buffer. So, like a common problem in low-level languages, like C and whatnot. Dereferencing a null pointer, and using untrusted input when calculating an array, so all your OAuth top 10, and then issues related, and there were also, the NVIDIA GPU driver also had some issues back in May, so like it's just kind of getting more of those vulnerabilities discovered. For GeForce Experience, so issues with game stream, attacks with local system access can load DDLs, and because GameStream can also record your screen, it becomes like another thing where they can it becomes another issue. So yeah, that's pretty much it. Cool. Yes. Okay. So this one talks about. So we all know IoT is tough for consumers, but industries have been widely adopting sensors in IoT devices, mainly to increase their automation or to increase their big data analytics or just decrease costs because of the things that I mentioned, it just decreases cost. So, for example, one of the ways is Emerson deploys a solution to detect when a part needs to be replaced. So they put an IoT sensor in to detect when the part is instead of replacing the part on a periodic basis, so like once a year or something. Now, based on the sensor, they can detect the wear of the part, so they're able to use the part for longer. Those types of things, or like Rolls-Royce using it for engine development. So yeah, there's an industrial internet consortium that's been formed, and it has quite a few big players like GE, and I didn't record, but some other brands as well, which is good to see. It's non-profit, and they're planning to release some guidelines around data protection, best practices for IoT devices. Microsoft also released one, so it looks like people are starting to form it. It's good to see that a bunch of companies are coming together to create a common standard, because that really helps the whole industry as a whole, and interoperability. So yeah. Oh yes. Okay. So Magneto is a popular e-commerce.
Magento?
Pardon?
Magento?
Magento? Yeah, Magento. I was hoping to just pronounce it once. I got it wrong. You wouldn't know. In any case, so they're a popular e-commerce platform. So similar to like WordPress, except they handle like online stores. And there was a major vulnerability. So the CVE score of 10 that got released. There have been groups that have been known to target these sites in particular, and the vendor is aware of sites being targeted, or threat groups targeting the platform with this vulnerability. So they're able to, with this, they're able to steal credit card information of customers of using their e-commerce site. The vendor released a patch, and basically it's a remote code vulnerability with an unauthenticated user. So the worst of the worst types of vulnerabilities, because like they need zero access. And this just also came on a few months back. They patched a couple of CVS scores of 9 or higher, and some cross-site scripting vulnerabilities. So yeah, the devs are having a bad year. So
just to flush out one of these pieces, we've mentioned MageCart at a few ISS meetings. It started out as like just a single piece of software meant to hijack credit card transactions on websites. I think it's kind of grown into like a collection of tools and groups using those tools, because they mentioned here the MageCart Association of Threat Groups. But that's if you're going through this article, that's what MageCart is. Basically, malicious code you inject into somebody else's website, so that when someone else goes to purchase something on the website and they enter their credit card details, it'll hijack that transaction. It'll still let the initial transaction go through, but at the same time, bad guy will likely like steal some money at the same time. That's what MageCart's all about.
Yep. Okay, so some AV news. So McAfee antivirus. So there was a bug in their antivirus software where basically the antivirus would try loading a DDL in the wrong directory. And then if it wasn't able to find the DDL there, then it went to the correct directory. So if you put a DDL with the correct name in the right path, it would first go to the wrong directory path and load your malicious DDL in. And because antivirus runs at a very high level, runs admin as an administrator and is pretty deeply engraved in the OS, you pretty much have like a really good mechanism for persistence. So I'd probably assume that this is good and you're able to also bypass security tools. So I'd imagine this is would be pretty good for like enterprise, if you want to exploit like an enterprise or so.
Mm-hmm.
I think you get some good experience, a good way of getting persistence that way. SafeBreach, the company claims that it privately disclosed the bug to McAfee, and McAfee already pushed out a patch. So patch your McAfee if you're running it as an antivirus.
Yeah. A bunch of different like tools were all apparently affected by that.
Yeah.
total protection. and all that
Well,
kind
the
of stuff.
McAfee software is all integrated, like, and works together and whatnot.
Cool.
Yeah. This is
Easy.
email compromise again. Man, I gotta practice the name beforehand. Nikki. Oh boy, Nikki.
Okay.
Yeah, basically, Japan's largest financial media organization. They suffered a business email compromise where their North American branch, so not their main Japanese branch, but on the American side, an employee transferred $29 million through business email compromise. So basically, a business email compromise is they're able to impersonate a high-level executive, and then they're able to use his email to trick an employee that has access to like transactions or so to send money to their account. So that's one of the ways it's becoming quite popular. We've covered it quite a few times at sessions. So yeah, the scam basically is, in this case, the scammer impersonated someone from management and was an executive, and the company already alerted the U.S. and Hong Kong authorities to recover the money. But yeah, we'll see how that goes.
Yeah, good luck with that.
Did they just transfer $29 million in one go?
The
Yeah,
article
that's-
doesn't seem to say, like, because the way that a lot of these things happen, like at least the ones that I've seen, it'll start off with like a request, and then maybe they'll do 2 or 3 more. When it's the one from the executive, it tends to be like, hey, I'm like off-site, I'm not near my computer, all that kind of stuff. I need this amount of money transferred to this business partner right away, right? And then they might follow up with, they've revised the quote. Now we need to add an additional this amount, because it's like the scammer is testing, right, to see how much they can get away with.
Yep.
Yeah, who knows though? Like maybe it might be common. What always gets me about these though is how the institution's own bank account doesn't catch these faster. Like some institutions are really good at catching these because they'll have all kinds of metrics. Like, oh yeah, you typically only do business from 9 to 5, but at 2 a.m. you transferred $5 million to China. Interesting. We're just going to put a hold on that for a day or two. Yeah. Or where's your like second employee who has to like, QC the transfer and like double authorize? Yeah.
Yeah, but I mean, it depends. Like, if it's a high-ranking person and you're
Yeah, exactly.
and you're used to making like multi-million-dollar transfers, anyways. Like, I think there was one guy that I was speaking to that worked in a did something with trading where he brokered transactions, and like $1 million transaction is like
Was
not a
normal.
big deal. Yeah,
Yeah.
it's normal.
Yep.
So like, yeah, and you know what, like, as businesses become larger, like Apple became the first $1 trillion company.
Something like
Like, imagine how much employees they have, and not only employees, but like the amount of money that they generate, right?
So at that point, they have processes in place to like catch them. So that
hopefully.
You would think.
But there's always exceptions, right?
Yeah.
Especially when it's an executive.
Yep. Oh yes, this one. So speaking of large enterprises, so basically, understanding the ripple effect of large enterprise data breaches. So basically, securing a large enterprise is hard, and it's kind of. I think there was a talk also at Sector that talked. So large enterprises, they suffer some unique challenges, and small businesses also suffer some unique challenges that make security hard for them. Middle-sized companies are doing, like, they're okay. And so basically, like, they're just talking about how, like last year, for example, 65,000 data breaches were reported and 5 billion records were compromised. So, like, the amount of data that's being compromised is only increasing. Large enterprise networks are more susceptible, and also large cybercrime networks are being organized, and they're able to attack these enterprises at scale, right? So.
Stranger danger. Sorry.
Yeah. Well,
That's awesome.
yeah, and also like these large enterprises, everyone is integrating with another and working with different vendors. Like, you can't be an isolated shop. Like, you got to work with people and integrate, right? And so it just makes it hard because we see so many times, we've covered so many times, of a third party that's a small shop being compromised, and then that, because there's a trust or some kind of integration point, they're able to go into a large enterprise and pull a bunch of data. And also, it's just hard to promote security across when you have like thousands of employees like spread over like a huge spread around the country or even the world. Just like even the likelihood of phishing attacks, like phishing campaigns, like they're able to send emails en masse and they only need 1% click rate, right, to survive. And so like if you have thousands of employees, that 1% is pretty good odds. And also like not patching systems, like forgotten, like turning off system, like decommissioning system, but leaving them in a rack, and then just someone, oh, that should be odd, and then just pressing a button, right? You never know. So a lot of challenges. Basically, managing your assets is something that businesses should definitely do, and yeah, not forget stuff. So yeah,
It's like that stuff in that first semester systems loss course is actually useful. Who'd have thought? Who'd have thought that? One last story that I threw up right before we started the news, because I totally forgot about it, but it generated some discussions, is this one. So some U.S. law enforcement body actually came out and said, hey, be careful about using these like USB charging hubs and stands and stuff like that in public locations, because it could potentially compromise the device you plug into it. It goes something like this, like bad guy opens up one of these things and basically inserts some kind of computing module so that when you connect your phone or device to it, you're not actually getting a charge, it's actually using the data lines over that USB cable to talk to your device. Their recommendation is basically just to always use the AC adapter with the cable that you brought, because there's no way to compromise that. Or if you're going to use USB, if you just go to like the dollar store and buy a cheap USB cable for, you know, USB-C or whatever you happen to use, it's very likely that those cables are cheap because they didn't build the data lines into the cable. There's only the power line and the ground line because they figure you're just going to use it for charging. If you actually have one of those cables and you can prove you have one of those cables, it's safe to use in even a compromised slot because there is no way to send data over that cable. The article cites research that has been done a few times. Lots of people have done proof of concept of these types of things where they've embedded a malicious computing module into one of these things. What the article doesn't point out, though, and this is something that I took a little bit of issue with, is they didn't give any actual numbers of this being done for realsies in the wild. Like, it's cool that they're talking about this type of research, and hopefully it gets people to figure out solutions that, you know, people can use to verify that a plug is safe and secure, or the device itself would be secured against these kinds of attacks. But like, there's no proof that this is actually happening for real in the wild. Can it? Oh yeah, totally. Does it happen? I don't know, but it would be nice to see stats on that before we go like scaring the public at large about using a charger at an airport or something like that. That's all. We like to really hype things up and use fear as an industry to sell things, and that's maybe not always the best approach.
Make sure you don't charge your vape device into your computer.
Oh yeah, will it draw too much current? And burn out your USB port?
Well, no,
Oh yeah, the malicious vape devices. Yeah, I forgot about that. Yeah, somebody like basically in a vape, they actually reprogrammed the small little microcontroller in that, so if you plugged it into your computer, it would like inject malware into your computer while charging your vape. Like, because USB doesn't just mean power. There's data, right? That goes over USB.
that's probably
Although I wonder, can you bend one of the pins like in the USB to block the data port?
If you just like ripped the pins out, yeah. But just go to the dollar store, man. They're all cheap.
Right.
Cool.
Simple.
That's it for the news.
Yep.
So yay. Good to do a code repo now.
Yep.
So this week's repo rundown is a tool called Witness Me that was written by Bytebleeder. The idea is that this thing, it will take like a list of URLs, either that you just generate, that you specify by like CIDR notation, that you get from running a Nessus scan or an Nmap scan. Basically, you feed this thing a list of URLs, and it will then go to those websites in an automated way using like an automated web browser that's headless, meaning you don't see the window. It'll take screenshots of the website and also collect a load of data, like server headers and IP information and all kinds of stuff. And it builds it into a nice little database that you can then query from the command line using a nice little interactive tool that the author wrote. It's actually a pretty cool project. it was almost like I almost bit off more than I could chew this week because I didn't realize that it's actually two separate programs under one project title called Witness Me. And obviously we have to include a graphic from Mad Max. The author's description of the tool, my take on a web inventory tool inspired by Eyewitness, takes screenshots of web pages using Pippeteer, which is basically a Python program that simulates running the Chromium web browser, which is like the parent project for Chrome. And it's, again, when I say it's headless, it basically means like the web pages are being loaded and rendered and visualized, but without an actual window that's being shown to the user. So it's all happening like in the background. It actually runs like, it was written for like Python 3.7, so the project is like super recent, which is awesome. It uses Python's asynchronous I/O operations, which make it really fast. Asynchronous I/O basically means I can just start firing off jobs and they will run in the background and the job will let me know when it's done. I don't have to keep track of any of that stuff. So it allows me to just start like firing off tasks as fast as I can program them, which is really cool. And it has a sick interface. Some features, I took the author's wording specifically because I loved it. Yeah, Python 3.7 and greater, meaning it's great. No dependency installation hell, works on a variety of Unix flavors. Yeah, you basically just run one Python command and this thing is installed. Async IO provides Mad Max speed levels. Headless Chromium is just straight up gangsta. Like, I love it. This author is now one of my favorite programmers ever. They did have a screenshot on the GitHub repo. It's a little bit hard to see, but the idea is like up here, they typed the word servers into this custom command line interface that they wrote for it. And it displays a bunch of metadata about the servers that were scanned, like the title of the web page, the URL, this part's cool, and we'll talk about this later, what it thinks the technology stack is that the server's running on. Based on some signatures that people can write. And then it actually shows you the screenshot that was taken, but the screenshot's like in your terminal window. How cool is that? Like, see graphics in your terminal. Like, it doesn't, you can have it load up in a separate program, like a separate web browser or an image viewer or whatever, but it freaking shows you an image in your terminal. Oh God, I love it. It's gorgeous. And also look at this table. Look at the like sick ASCII table. Like, they got the little plus when two lines cross and just dash it. I'm a sucker for like sick terminal stuff if you haven't figured that out. So what does this code repo look like? This is the top level folder. So there's a folder called Witness Me that has this bunch of supporting code. This is all just stuff for GitHub and pip, which is a Python tool for library installation. A requirements.txt file. So when you download this thing, you run pip install -r and you point it to this file. And it installs a bunch of third-party libraries that are all Python utilities that this program needs. And this is the part that got me when I first started it. See here, it actually is two separate programs. There's witnessme.py that actually takes the screenshots and records all the server information. But then this tool that like shows you the sick-ass tables and stuff is this second tool down here called wmdb.py. So the idea is you run witnessme first to build a database, and then you run this tool second to interact with and query your database. The support code, just stuff to like talk to database, to parse command line arguments. Signatures, which I'll show you later, but they look like these. They're just configuration files that tell you a few lines of code that you should see in a certain website to be able to determine, is this like a Cisco product that's rendering a web page for me? Is it like an Apache Tomcat website, something like that? And then just some miscellaneous stuff for stats and utilities. So like I said, it's two projects in one. The first one, witnessme.py, basically takes a list of URLs, and then it uses this headless web browser to screenshot each of those URLs, page, whatever that is, and records a bunch of server information like the HTTP request headers, the host name, the IP address of the host, and stuff like that into a little SQLite database that's basically a database in a single file that lives on your machine. You don't need a big-ass database server. It's just like a data file. And then wmdb.py gives you a cool little terminal program to query and display records from that database. We also use this program to scan the database for signatures to try to identify maybe what web service or what technology stack those servers were running. I'm not totally sure why they separated it into two utilities. Like, it's possible to present this maybe through an interface in this tool, but maybe the author is still actively working on it, or maybe there was some design decision, like you run this on one machine and then this on another machine. I'm not sure. A couple of highlights from the requirements.txt. because I just like to point out cool Python libraries if you ever want to go use these tools in your own programs if you like writing in Python. ImageCat is that library that lets us render an image in a terminal, which I think is the coolest thing ever. Prompt Toolkit is this thing that they used to design this little menu-based interactive text completion menu system that they have. Again, it all runs in the terminal. This thing just makes it really easy. And Puppeteer is the headless Chromium browser. This is all just supporting stuff. Although this thing, terminal tables, is what draws that sick ASCII table. So in the main witness.me.python file, some initial setup. It does a butt ton of imports on random things. Important stuff is threading and async IO for asynchronous code and making it really fast. And Puppeteer, the web browser. It also configures a whole bunch of logging. I don't usually go into logging, but it's there. Main parses a whole bunch of command line arguments like, what's the target file that you're giving me? Is it a list of URLs? Is it an ISSessions scan? Is it an Nmap scan? What is it? What ports do you want to scan on? How many threads do you want this thing to run? And the default is 25. Like, this thing is making like 25 requests concurrently out to websites, so it's meant to be damn fast. So you could run this on some pretty beefy hardware and it would complete really quickly. How long do you want to wait for a website to time out before we stop the request? And then we parse all those arguments. This is another sick part about interpreted languages like Python. Since we don't compile Python or even compile the libraries that we're working with, the author wrote this function right here because it was a problem that they were having with Puppeteer actually timing out on websites before completing the work. So they wrote like a real-time patch for this. So every time their program runs, it applies this patch to the library they implemented. That's cool. You can do this because you're running interpreted code, meaning stuff that hasn't been compiled. It kind of recompiles every time it runs. That's badass. They set up an output directory, and then it runs a job called start scan. What does start scan do? Well, first off, it creates a database to hold all the results of the scan that we're about to do. Okay, and it basically kind of connects to it and builds two tables. One table to hold information about the hosts that we're going to scan, the host meaning like IP address, host name. Another about this, the services that are running on that host. So we're going to record the URL in here, the screenshot, or actually a link to a screenshot that's going to live on our file system. The title of the web page that we're requesting, stuff like the headers from the HTTP transaction, the entire body, meaning HTML content that gets returned from the request, all that kind of stuff. So basically all the content of the web page lives here, and high-level info about the host lives there. Then what StartScan does is creates a great big queue. So this is going to be a great big list of all the URLs that we're going to scan. And then it tells producer, which is this function down here, to just go and read all of our command line inputs that we gave it, parse those out, and fill this queue full of URLs. The reason they had to break it out into another function is, like I said, we can either give it an Nmap scan, we can give it a ISSessions scan, we can just give it a CIDR range. This thing knows how to read all those different input formats, but basically just converts all of them into plain text URLs, and we add all those URLs into this growing queue of things we're going to scan. Then we launched Puppeteer, which is our headless web browser. We just kind of create a fresh version. This part's interesting. They had to add the attribute no sandbox because they kind of need this thing to run as root for some reason. I guess to the way it takes screenshots and does stuff, it needs that permission. Then it creates a pool of 25 worker threads and tells each worker to run a function called worker. And then it basically just sits and waits for all those workers to finish. The workers will finish when the queue of URLs has been completely consumed and is empty. So basically these 25 little worker processes will go off and keep reading URLs and scanning websites until the queue is empty, and then they all kind of wrap up. They inform our program that they're all done, and then this is in theory where the program will then just terminate. At that point your database is done and it's loaded and it's ready. Now, what does that little worker function do that all the workers are running? Well, basically, while true, meaning forever, grab a URL from the queue. Okay? When you have that URL, pass the URL and our web browser, which at this point in the program is called page, to a function called screenshot, and then wait for it to complete. That's what async IO await means. Wait for this job to finish. When we get the data back, just load it as a record into our database by adding the IP address information and all that kind of stuff. So that's it. Basically just go do screenshots, collect info for me, load that into a database, and then the worker just loops back and grabs a new URL and keeps doing that. But again, keep in mind we have 25 of these things doing that. So it'll consume that queue really quickly. Okay, so what does screenshot do? It's pretty straightforward. This is the code with that Puppeteer library to go to a URL. So your object.goto, some URL, and then if you want to pass it any options. The author of the program said, well, wait until network idle 0, which in the context of that Puppeteer library means wait 500 milliseconds for the page to finish rendering and loading. They did that because they wanted like all the JavaScript and the style sheets and all the images on that page to be loaded before they took a screenshot. Okay, so that's the code that basically says, go to this URL, load the page, wait about 500 milliseconds for all the resources to be there and load it into the page. Once that's done, grab me information like IP address, host name, port number that the web server was apparently running on. Grab all that and kind of hold onto it for a minute. Then we go and take a screenshot. So the first thing they do is basically create a file name for the screenshot. They're all going to be PNGs. Then we basically build a path that we're going to store that screenshot in. So the output folder and then the name of the screenshot that we just built. And then that Puppeteer library just has a built-in function called screenshot. So again, keep in mind this web browser is hidden. You can't see it. But you can tell it to take a screenshot of what it sees right now. So we'll take that screenshot, we give it this path that we've just created up here, and it will save that screenshot to that path. Bam, there's your image. So that's cool. At that point, the screenshot function that we have, it will return a whole ton of data about that transaction that it just did. So IP, hostname, the URL, the path to the screenshot that's now saved as a PNG image on our file system, the port, the scheme of the URL, which is like the way it was structured and mapped out, the title of the web page, all of the HTTP response headers that we got back from the server, which is interesting because it might have cookies and stuff like that. And then the entire body of the web page that was returned as HTML. So we get a lot of data back, and it's returned as what we call a Python dictionary that we can work with later on. So at a really high level, this is how WitnessMe works. Set up logging, parse the command line arguments, create an output directory. Then you run start scan, which creates a database. It populates that database, or it populates a queue full of URLs to scan. Then we create a butt ton of workers. They all pull URLs, go to the address using a basically invisible browser, take a screenshot, record a bunch of details about the website it just got, and it loads all those results into a database. So by the time witnessme.py is done running, you should have this SQLite database with tons of information in it. At that point, you fire up wmdb.py, which is the other program. It's also got an ass load of imports. So again, some stuff around asynchronous I/O operations to make things fast. A couple of neat libraries for rendering content. Web browser, which is what we can actually use to have an image load in our system's default web browser, which is cool. There's that image cat thing, which shows images in terminal windows. There's terminal tables, which builds sick ASCII tables from data. And then all of these imports from Prompt Toolkit, or what the author used to build their nice little command line menu system that has like text prediction or text completion and stuff. It's pretty awesome. It also sets up logging. Yay, logging. So again, it parses command line arguments, and then basically it just builds an object called wmdb shell, which they define in a minute. And then on that object, they run this forever. So it's a little function called command loop, which just sits there and reads commands that the user's typing in, queries the database, shows you some results. So this is it reading a command, self.promptsession.prompt. And then it splits the whatever you typed into like a command and all of its various parameters. And then based on what the user typed, it's going to run one of these 6 functions. So exit, pretty obvious what that should do. Show, open, host, servers, and scan. Show, all it does is query that database, and it shows you the screenshot for whatever server ID you gave it. Okay, so I can say show server number 1, and it'll show me the screenshot from server number 1. That's exactly what was shown in the screenshot on the author's site here. So first they listed the servers, and then notice ID number 4. So they said show 4. So it shows the screenshot for server number 4. That's so cool because it draws an image in your terminal. Open is the exact same thing as show. It's going to just show you the screenshot from that server, except rather than drawing it in your terminal, maybe you have a crap terminal that doesn't support this, I don't know, but it'll actually launch your system's default web browser and load the image in that instead. That's kind of cool. So that's open versus show. Hosts queries the database either for an individual host, meaning a server, if you gave it like an ID number or something like that, or if you just say hosts, it'll just show you all of the hosts in a great big list. Okay. Yeah, this is where it will query the database for like IP address, hostname, stuff like that, and then draw it in that sick ASCII table for you. This is how the drawing of that ASCII table works. It's a little bit complicated, like I had to sit and read this a little bit, but basically it builds some headers for the table, it queries the database, it iterates through those records that have been returned and kind of builds an object for Python and then passes that into that ASCII table library that we imported, and this thing knows how to draw a table on your command line. That's really cool. I'm going to steal that and use that for some projects because I like the idea of showing tabular data in a terminal. That's really neat. The scan function, which is actually really fascinating. This is where earlier on I showed you that signatures directory. So what will happen is running scan will read all of the signatures that either the author wrote or that people have contributed to their project. It'll read all those signatures, and then it will start to go through all of the servers that you scanned and see if any of those servers match the signatures. If so, it'll mark it as matching a signature, and then every time in the future when you like list the servers, it'll show you which signatures it matched. It does this just by like just brute text comparison. So for example, we saved all of the HTTP request headers. We saved all the body of the web page. It will search all that text for the signature that someone has defined for us. So this is probably going to be a very like CPU and actually disk intensive process. So this probably takes a little while to run. What does one of those signatures look like? Because anybody can write these signatures. They're written in a format called YAML, or YAML, which is yet another markup language. So this is what the signature for Apache Tomcat looks like. Ignore the credentials part because I think this is like a planned feature for later. But the idea is here are the signatures that would tell this program if a website I received was likely being hosted as part of Apache Tomcat. So it looks for text like the opening header tag and the word Apache Tomcat, or it looks for manager application how-to as just a plain text string. It looks for span tags with manager app in between them, and the string apparently for security, comma, access to the. Apparently these are all very unique strings for Apache Tomcat. So it will basically just search through the returned web page for all these strings, and if it finds them, then it's a Tomcat server. The signatures directory is massive. There are tons of signatures that the author wrote, and probably some that other people have contributed, because that's a pretty straight up signature format to write, like name and then the whatever I'm trying to match, and then I just put text of what I'm hoping to match. That's really easy. So again, the high level operation of WMDB is logging and parsing, and then create this shell object and call command loop, which just sits there forever reading commands from us and doing something while connected to the database. So again, either show the screenshot in the terminal, open the screenshot in the web browser, print a table of servers and details and stuff, do all that scanning and pattern matching of the signatures, or just exit the program. And that's it. It's a pretty cool tool. I'm actually looking forward to playing around with that a little bit more. The last update to the project was like just a few days ago, so it's obviously still under active development by the author. It's neat. Go use it. Yeah, so this is amazing if you're doing recon on a company for a pen test. So for example, you're likely given a list of their IP addresses, right, or their IP address range before you start a pen test. I would feed those IP addresses into this thing, and it's basically going to enumerate your IP space for me so that I can know, hey, are you running any web servers, any web applications, stuff like that. And rather than me having to sit there and load a web browser, maybe I ran this thing off of an IP address that I can then delete afterwards, and now I've got this cool database of screenshots, information about the server, and then now from my more protected machines, I don't have to go visiting all your IPs. I've got all that information summarized for me. It's the kind of thing that, like, I don't know, maybe if I was doing a pen test, I'd like run it at night before I go to bed, and then get up in the morning and I'm ready to start my workday because I have all the data that I need to start, like maybe application pen testing or something. That's likely what it's for.
From a defense side, just having an inventory of like.
Yeah, also probably just useful to scan your own internal environment. Yeah, because I know this author, I don't know them personally, but I know that they are a pen tester. And when they get bored of doing pen tests, they say that they just go write code for fun. So I assume that they wrote a utility to help them with their day job, which is probably some kind of web app testing. That's my guess. Yeah. Any other questions? No? Cool. All right. Thanks.
Okay,
Okay, good friends, you good to go? Oh, I know, never mind, I didn't know. Is that? Yeah, for a little bit. How's it going? Stuck at Burkhead. The trains, that first day when it snowed, they were like something like, yeah, like 2.5 hours behind. Yeah, okay, you got caught up in that, I would assume. Yeah. Control. So, starting to rush hour.
Hey, what's up?
Do you want to set up?
Well, do you need your slides for the?
I do need my slides, yeah, but if you just want to I'll just go over.
Because I'll move my laptop on there. Right?
Thank you.
It's something that your computer does.
Okay, so it should, if it's not working, talk to you or something.
Alright guys, if everyone could come back. We're going to get started with the feature story.
There's a microphone.
Hello. Just like announce the talk, the speakers after as well. Because you're after.
If I could just have everyone's attention. Why? Okay. There's a microphone here. I only discovered this microphone was here 2 meetings ago. It's very useful. Alright, I'm gonna get started. Okay, so this is our feature story segment. I'm pretty sure everybody here knows what it is, but just in case. This is a chance for you to participate. Your input, like I'm just a facilitator. It's your opinions that we want, so please participate. I'm probably not going to be able to get through the whole story because we're running a little bit over time, but I'll try to do my best. Okay, so the feature story is this week is about Twitter and Trend Micro, and it's about insider threats. So I just wanted to kind of go over the stories first, then I'll ask you a few questions. So at Twitter, 2 Twitter employees actually ended up spying for the Saudi government. So they were hired by the Saudi Arabian government to spy on a whole bunch of accounts. And essentially what they were looking for is dissidents. And dissidents meaning people that have either defected from Saudi Arabia or people who criticize Saudi Arabia. And so it's a case of sort of like cyber espionage. They were paid roughly $300,000 and then another $20,000 hublo or hublot. I don't know how to pronounce that. Hublo. Hublo? Oh, okay. So I'm not proper. Yeah. And then, within the same week, a rogue Trend Micro employee, gained unauthorized access to a customer support database, and he ended up selling a whole bunch of accounts to this crime syndicate, and then this crime syndicate started actually selling those accounts started contacting those customer accounts, for phishing emails. So pretty embarrassing story for Trend Micro. I know they're also our sponsor, so if they're listening right now, I am so sorry. That's the last I'll probably mention. So yeah, now you know about the story. And I guess like my first set of questions is, what do you think? I mean, are insider threats like a big deal within organizations? If you had to take a guess as to what percentage of data breaches were a result of insider threats, what would your guess be?
Are you considering like maybe not even them being aware of it happening? Like in some cases, like when you watch TV and somebody's like, "Oh, I'm just gonna start dropping USBs on the floor, hoping somebody picks it up, find out, okay, I'm gonna see what's in it, and then boom, you're in." Would that be considered like an insider threat, or it's more like an accidental kind of thing? Like what?
That's a good point. What do you think an insider threat is?
Well, sorry.
Yeah, no.
Well, it would be basically somebody internally sabotaging or trying to get benefiting from the company itself in the means that's illegal or unusual, right? That's what I would consider that.
Okay.
Insider threat is supposed to be intentional because that's what separates like people that just get caught up in it, but you can't classify them. You wouldn't classify them as an insider threat because they just weren't knowledgeable of it. So if they click on a phishing link, that doesn't count as an insider threat.
Okay, interesting. So, do you guys think that like something that is accidental could be considered an insider threat? So, if somebody is on a database and all of a sudden drops the entire customer table, drop table customer or drop customer. I don't know my SQL. Okay. Yeah. Do you think that is considered like an inside threat, just like accidental stuff?
Yeah, it's like an inside constant threat, but not like whoa, this is a threat to the company. What you did, Billy. It's not that kind of. It's a different kind of threat, I guess. That's always there. mistakes can always happen, I
Right.
guess.
So you don't think it's an insider threat?
I do think it's a
You
threat,
think
but
it's
that's like
okay.
a different kind. I think that's like a constant threat. Whereas I guess this is constantly possible too, but this is more like, you know, you don't expect it from someone that you've like put through training and like he's friends with all the coworkers and goes out and actually does like, you know, selling customer information or different kind of threat. I think they're both threats, but one is different than the other.
Yeah, for sure. I mean, most definitions will include both accidental threats and will include things like, you know, malicious intent, right? Like a disgruntled employee or something like that. In terms of going back to that percentage, so it's roughly 34%. So 34%, you know, across all industries are attributed to insider threats. So it is a pretty big deal. What do you guys think they're usually like motivated by?
Money.
Money. Yeah, money is a big one. In the case of Saudi Arabia,
Watch.
what's that? The watch. Yeah.
I would say it's a waste of time.
Yeah. I mean, the two people from Saudi Arabia, I guess, were motivated by money, but Saudi Arabia is motivated by politics, right? You know, this you could consider this like a cyber espionage case.
But it could also be like threats directly, right? Like if I know that blank person has access to something and I want it, what would be the easiest way to manipulate them? Maybe I don't know. Maybe I'm going a little bit into the Hollywood side of things, where it's just like, hey, you don't want to get hurt. Like you personally don't want to get hurt, or you know, things could happen if you don't do what I want. Type of thing.
Yeah. So like intimidation.
Yes.
Is what you're saying. Yeah. Yeah. No, that's a good point. You know, I'll just go over really quickly. Why does the business care? Frankly, if it actually is that many, right? Well, and you know, in the case of Twitter and Trend Micro, and you get like 68,000 accounts, and that's an antivirus company, right? That's very embarrassing. So it's reputational damage. And then the second thing is that it's also financial damage, right? Customers are less likely to pay, you know, to go to you if they know that you're insecure. So you know, this is all the basics. What I really wanted to get to was like the challenges of actually implementing a plan to detect insider threats, right? So now so we have that baseline, what are insider threats? But how do you think you actually detect insider threats, right? So let me put you in a scenario, right? You are the CEO of notinsiderthreats.ca and
Is that the main taken?
You have to implement a plan, right, to detect insider threats when they happen. What would you do?
Well, I mean, you have, like, we keep mentioning all the time, right? There's a time and a place when people do stuff in a regular environment, right? So, for example, if somebody tries to access the office at 2 in the morning on a Saturday or at 3 in the morning on a holiday, they untypical, they usually will tell you, hey, somebody could be considered a threat, depending what they're trying to do, depending on the level.
Mm-hmm.
You could also say, like, if I'm working on the company and somebody's acting odd, like if somebody from accounting all of a sudden starts writing somebody in the upper layer of the C level and this person doesn't have access to it.
Right.
Why are they doing it? How did they get there? This would be some of those few things.
So you mentioned two things. One is access outside of working hours, right? And then the second thing is just unauthorized access to data, right? Let me put you. Oh, so did you have?
I heard an interesting suggestion about using AI to gather heuristics about persons, like build a profile.
Okay.
There's different products out there that do that.
Yeah.
That's interesting. So what you're actually saying is you kind of establish like a baseline of behavior, and then if somebody veers off of that baseline, you trigger on that, and then you actually have to go and investigate.
You just throw the data at an AI and say, is this, and generate a risk score based on what they're trying to do. So you don't have you don't set rules traditionally.
Mm-hmm.
You just set up the pipe to feed the data to the algorithm or machine learning, and then it generates a risk score, and then based on the parameters that the AI determines, generate a risk score, and then decide what's acceptable and what's not.
Yeah.
It's not AI, it's actually called user and entity behavior analytics.
Woohoo.
There you go. I just heard someone. Yeah, I heard someone saying it. I was like, okay.
Did you have a point, Clinton?
There's also another product being developed for, which is DLP, which is data loss prevention.
Okay.
It monitors files that we mark as critical, like customer data. will it monitor on endpoints in case of like someone is touching that data, and then if someone touches that data and then sends it elsewhere, it notices it's traveling through the network, it might flag that.
Okay, interesting. Actually, Owen Cummings, I don't know if you guys know him, but he mentioned like a couple of good points to me that sort of relate to that as well. So if like somebody tries to upload like a ton of data to their personal Google Drive, you can actually inspect the packet and then you can see, oh, this is where it's, you know, going. Oh, this is a personal account. Oh, this is like a ton of data. Maybe we should investigate, you know, what's happening, right? It's the same thing with like emails that are going out at like constant intervals, for example, right?
The thing is DLP is really hard.
Yeah.
Because you have to categorize the data, and like there's different, it can take on different forms as well. You can hack it in different ways, and also the type of data that is personal, like it's not as clear cut because tons of people will have like tons of Excel spreadsheets of random stuff, right, or reports, right? You can't keep track of it all. It's hard to do.
Yeah,
right? There's different technologies. There's not, DLP is not one solution. It's a multitude of capabilities within DLP.
Right. So the implication here is that at the end of the day, you're going to have to monitor your employees, right? Are we agreed on that?
Yeah.
Okay. So if you knew that, if you knew that you were being monitored at work, right? First of all, is that something that's common, like to your knowledge?
Yes.
Yeah. Okay. It's something that's very common. You know, I guess what I'm trying to get to is to what extent is it acceptable, right? And I thought that this is kind of like really hard to explain. So I thought I would actually put you through a few different scenarios and then sort of tell me how you feel about the scenario. And by the way, all of these three scenarios are like real. Okay, so they are happening or they are about to happen. So the first scenario is you're an Amazon warehouse employee and you have to wear an ultrasonic bracelet to work that detects your location as well as everything you place in and out of bins. So you're in the warehouse, you remove things, you have this bracelet on your hand, it knows your location at all times, and it knows exactly what you've put in, exactly what you've taken out. Do you think that's like a privacy problem?
It depends.
Okay.
It could be. I mean, if we're gonna be doing the same thing that we're doing with security cameras, right? Where I know where I can see you doing and where I cannot. For example, will it detect when I go to the bathroom? Will it know where I'm at all times, right? But if it's something like Amazon, in this case, because you're talking about Amazon, is if there's a box here that says these are supplies, and you should have access to supplies, and you start taking supplies out of it, and then I realize that you're also heading towards the exit, I will be able to say, hey, you're stealing supplies. If I have to move product, like there was a case at UPS where somebody found a game of Call of Duty Modern Warfare 2 and the box split on the floor. And the guy stole one of those. And then they caught him, not because the security system caught it, but because the guy went home, put it on his Xbox, tried to go online, and then went complain on the internet saying why there's no people on the online server 3 days before the game came out.
Interesting.
So for stuff like that, could be, yeah.
Anyone else? Does Amazon have like a theft problem? Do you think a lot of people steal at Amazon in their warehouses?
Maybe.
Yeah. No, definitely. So there's a lot of theft. Like, and it's it's a huge problem, and it's actually like I didn't work for Amazon, but I worked for Best Buy, and at Best Buy there's like something like 2% of their revenue every year goes away just because people steal things, right? And that's in a retail store where there are cameras watching you at all times, right? It's not in a warehouse where the majority of people are actually your employees.
I was just gonna say, with the Best Buy thing, you mean that those are customers as well as, like, mostly customers?
Mostly customers, yeah.
So Amazon, yeah, it's all just people that are
Employees, exactly. Yeah, I mean, from my opinion, like, no, this is not really a privacy concern. Like, it could be. My issue with this is like a trust issue. So, like, I think you should trust your employees to kind of make the right decision. If I have to force my employees to wear this bracelet, it's kind of like I'm saying that I'm going to build this culture where there is zero trust, and I am just going to monitor everything that you do.
Like, is it the employers that are building that culture, or is it the employees that are building that culture by you seeing there's like an overload of stealing? So,
Right.
you know, when Amazon first formed, it's like, oh, welcome to, you know, working for Amazon, here's your bracelet. It's like, no, it's been how long? And after all these years of people, you know, taking advantage maybe, it's like, dude, you know what, like, I can't keep letting you guys take everything from my...
I don't know, maybe if you had like a corporation that has a lot of money and you paid your employees more like $15 an hour and didn't time their bathroom breaks.
That was the first thing I was going to say. I was going to say, if this wouldn't be an issue if you just paid. That was actually the first thing I was going to say, but I didn't bring it up.
Yeah.
I mean, totally. That makes a huge. I didn't know that was like one of the things that we should be
No,
talking about.
100%. And this goes back to like a point that I was going to make later, which is like, what is the root cause of insider threats, right? Like, is it the employee's fault or is it the company's fault? Because
theft is caused by opportunity. Right?
True. Yeah.
If you see like all the incidents that you mentioned, it's an opportunity. An employee saw an opportunity that there was a game left unattended. They knew that they could get away with it, so they did that. They weren't criminal by default. I'm sure a lot of us ourselves, we wouldn't consider ourselves thieves, but I'm sure like we've seen an opportunity, right?
Absolutely. Yeah. And I think like there's. Sorry, Nick. Do you have a point?
Yeah.
Oh,
In the practice itself, it's like an implementation of something we say in security all the time, right? You trust, but you verify. They're implicitly trusting the employee because they're saying, yeah, you can go into that bin without having to like sign in, without having to unlock it. We're giving you free access to this thing, but we're also going to verify that you did what you said you did.
Interesting. Okay.
So.
No. Yeah. That's a fair point. I think like what I would say to that is, yeah, there's always going to be theft. There's always going to be that baseline. But we can also say that there are going to be factors that will increase theft, such as what Elena mentioned, like poor employee satisfaction, not enough pay. Caring about your employees does matter, and it will reduce some of those root causes. The second scenario is, so you're a Walmart retail associate. The store has a system that allows corporate to listen in on your conversations to ensure you are not greeting customers, that you are greeting customers properly, so you're not being rude, racist, sexist. It also listens for like rustles in the bags. So if, for example, like you're not filling the bag fast enough, they'll actually detect that and say, oh, this guy's not being productive enough, or this person's not being productive enough. But I mean, the bigger privacy concern there is the fact about monitoring conversations. Would you be comfortable with the company listening to every conversation that you are having if you were a Walmart employee?
The conversations you're having in the store, I guess, while you're working. So,
Yeah.
I don't know if it's necessary though. Like, if a customer comes out and says this guy was, sexist towards me or something,
Okay.
it's going to be a bad situation for the employee anyways.
Well, would a customer come in to the store to be shopping if they're going to be reported too?
Yeah,
it's an interesting
I
point.
was going to ask that. Can you use that in the same area? Because a lot of times happens that you go inside of the store, let's say for Walmart in this case, and the customers, they are completely rude and they're jerks to you, and they're actually doing the same things that this device is preventing you, the employer, to do to them. And if you say, hey, I need to get a manager over here, and then they say, what happened? It's because this person's being rude to me, and then they say, no, I didn't. It's like, hold the recording.
Okay.
Help me here.
Right. So you're saying
will it be like a double
Yeah.
edge where if it happens to the employees themselves, Walmart will back them up, or if it only applies to when the employees are being when the employees are against the customer? Because if you're doing it one way where it's only for the customer's benefit, then I'll say no. Because if you and I were talking about something and I say something that I shouldn't, we could get terminated or we could get in trouble. But if a customer is being rude to us, and we have to prove saying, hey, this is what's happening, help me out, then maybe.
Okay, so you're saying actually like you can now verify from both sides if a negative conversation has happened.
Yes.
Yeah, which is really cool, right? I mean, that's probably a positive outcome. But at the same time, the customer, now we're listening in on the customer and now we're listening on the employee, and you've got like this like helicopter parenting basically, right? Where you're literally trying to control everything. And again, it goes,
Customers are talking to each other too. They could be there with husband and wife talking about like some personal stuff, or the phone call could come in and it's like personal. Like, it's not just employees that are talking in that store. Obviously, we already talked about customers, but also customers talking to other customers.
And then I lost the slide. Okay. No, there it is. Okay. Yeah, and then the third scenario, really quickly. So to cut cost and improve convenience, your company has implemented a BOID program, right? As a consequence of the program, they have full access to your personal data on the device. Is that okay with you?
Oh.
No? Okay. Tons of companies have this, right? Where they tell you, okay, bring in your device, and most of the time, people will mix in personal data with business data, and your company will be listening, right? In Canada, is there a law preventing this? Do you know? No? Would you want a law preventing this?
I'd be okay with it provided the law stated that the company also had to give you the option of using a company supplied device.
Okay, yeah.
So like, yeah, we'll let you bring your own, but you got to install this monitoring software, or you can use a device we give you. So you can then keep your personal life separate.
Right. Yeah. That's a great point, right? Because the problem with that though. What's that?
Third option, no device.
No device. Oh.
Or no device. Yeah.
Third person.
And so we don't
Consulting with law.
we don't have to do anything as security people if there are no devices. So that's like a really good point, right? And a lot of companies nowadays will sort of give like the employee sort of like a budget and say, okay, you can buy a company device, please keep all your personal information off of it, right? And that's something that's there. Going back to the point about like, the law, there is actually in Canada and the US, there is no need for consent whatsoever, right? So companies, if that you're going to be doing work, it's something that they are freely able to do. However, really interesting, in Europe, privacy laws have obviously gotten better with GDPR, and there you actually have to get the consent of the employee, and you have to speak with them and give them bullet by bullet, what information will you collect if this situation was to arise. All right, so yeah, that covers privacy concerns pretty well. Another point that I kind of wanted to walk you through is, we've talked about monitoring, right? So you can have like what do you call it, a seam, right? Somewhere somebody's watching things, they're writing rules, they're waiting for triggers. But what about, asking your employees to actually monitor for insider threats for you? Is that something that as a manager you would be comfortable doing? Is that something that as an employee you would actually comply with?
Yeah. There are in certain workplaces, as you said, you work at Best Buy, and I used to work at Home Depot, right? Like we have our own system where if you see a coworker doing something they shouldn't, like giving them a discount or getting free things, or even if it's just simply just taking data or information or something for themselves, we have a line where we say, hey, I need to call this person because so and so is doing this and this. But actually, for that is Home Depot just passed a new mandatory system for all of their employees, because some of my friends still work there, where you actually, if your manager asks you to hand in your device, you have to give them your personal phone, even if you don't use it for work. Like if I'm walking around fully apron on,
Right.
and I pull my phone out to do something, and my boss says, hey, I want to see what you're doing, you actually have to hand in your device.
Wow.
And just give it to your boss.
Interesting. I don't know if I'd ever do that personally.
The thing is, that's what people were saying, but the thing now is they're making it a mandatory thing where if you don't sign it, you are shown the door. Where it's like you have to do it. But then that lands on what we were talking in our class with Nick before, which is like, if I give my phone but I don't unlock it, what are you going to do about it?
Yeah. No, that's fair. So if that's not something that you would be comfortable doing, do you think that there's a way to do it? Like, would you give, like, say, okay, $1,000. If you catch another employee, we'll give you a payout of $1,000.
Because you get an issue with bullying, and he said, she said, that's
Okay.
that's not a good idea.
You don't think so? Okay. Best Buy has that. Yeah. That's why, and it would get really awkward sometimes, right? When you kind of have to, like sometimes you're doing something in the warehouse and somebody will start asking you questions and you're like, dude, I'm just like grabbing something for a customer, like relax, kind of thing.
Negative work environment, right?
Exactly.
It's hard to retain talent. You have that.
Yeah, so again, going back to that point on like privacy, how much do you actually trust your employees, right? And then, what kind of culture do you want to create? Because there can be a lot of education, you can foster awareness, that kind of thing, but you need to do it properly. You need to do it in a way where you're not also just telling your employee that you don't trust them.
Just have a program that can accept anonymous, like an anonymous hotline.
Okay, that's a good idea. Yeah.
Loyalty among your employees.
Yeah.
To be able to report.
That's fair. No, that's a really good idea. Okay, what else did I have there? Okay, so we covered sort of detection. How you guys actually kind of mentioned this, so I'll just run through it. So how do you prevent, like, mitigate the impact of insider threats? So DLP was mentioned. Just basic security stuff like identity management, making sure there's attribution for everything that a person does. Things like privilege analysis, figuring out, okay, do they have too many privileges? Do they have too little privileges? Yeah.
We haven't touched yet offboarding.
Offboarding,
If an employee
okay.
gets fired, make sure that their access is revoked before you tell them,
Right.
so that they can't, because there's a lot of situations where someone gets fired or they know they're gonna quit, so they're just gonna they have a list of clients, take copy.
Yeah. No, that's a really good point. I don't know if this is actually true. Correct me if I'm wrong. Wasn't it Capital One, right, where they had an employee who still had access after they were fired, or they had knowledge of the internal environment?
That was an Amazon employee that hacked Capital One. So
Right.
Sorta, because she worked for Amazon, she knew the system pretty well,
Mhm.
because she was exposed to that environment
I
and
see.
stuff. So
Yeah.
definitely, there is.
And I think that actually kicked off a debate about how, your insider threats are also that extends to sort of the third parties that you work with, which is a really good point as well. Okay. One story that I kind of wanted to tell you, I did an internship at another organization, and I just wanted to kind of, ask you, but before I actually tell the story, is, what do you think happens when you have way too many controls in place? And you're sort of like breathing down people's neck. What happens?
You lose.
Sorry, somebody raised their hand?
Right here.
Oh, sorry.
People find ways around it.
Yeah, 100%. To go back to that story, I was working at a company, I was doing an internship, and the whole department sort of collaborated together to bypass budgetary controls. So it was like a really big deal. It was somewhere in like $10 to $15 million, right? It was with a major bank that was overseas. And so the Canadian government has to actually audit all the transactions that are above a certain amount. But the way that you can get around that is actually if you split the transaction into two kind of separate pieces, and you say, oh, I'm selling this piece of software, but it's actually in two different modules, right? I'm going to completely, bypass this control. And what happens then? You actually end up putting the company at risk there, because if somebody is doing an audit and catches wind that, oh, these two things are actually like related, they can't work without each other, right? Then you've just opened the company to liability. But the whole department did not care about this, because what are they thinking about, right? Are they thinking about like security and auditing and insider threats? No, what are they thinking about? Yeah, getting the job done, sales, right? And that's another challenge that, when you're in the industry and you have to implement these programs, you're going to find it's like security is not what people are thinking about at all, right? And then how are you going to make them think about it, and how are you going to make them go through those processes? And then how do you make those processes in such a way that they are not too rigid and that they are followed, right? So there's a balance there as well.
Well, that's how they were laundering money in the 80s in the U.S. Because people, when money started coming from South America, they actually imposed a system saying that any transaction above $10,000 needed to be recorded. So what did? They show up 10 times a day with $9,000.
Yeah.
So they enter a record, and then they're laundering like billions of dollars that way.
Mm-hmm. Yeah, I mean, it's become a lot more sophisticated than
I'm
that.
talking about the 80s, but
Yeah. Oh yeah, right. Okay. But yeah. Yeah, we've already covered this, and what is the fundamental difference? I'll conclude here. The fundamental difference, between like an insider threat and an outsider threat is that you can spend as much money as you want combating external threats, and that is going to be, perfectly okay with, with the people in your organization. But with an insider threat, there has to be, every time you promote somebody, right, you're giving them more trust. You can never be 100% sure that that person is not actually, working against you. And so it's something that you're going to have to take prevention, mitigation, and take detection, and put them together in order to create a plan that actually, combats that. Okay? So thank you very much. That's the feature story. And now we will have Mr. Task and they're going to be talking about living off the land binaries and scripts, or LOLBAs. Hopefully I pronounced that right.
Do you guys want to stream your talk or no?
Sure.
Yeah, cool. So basically just present, and that'll project, and it'll present it. No, it's fine. There's a plug up here too. Oh yeah. That's better. Just get the one for my laptop in here. So okay, what time do you have? That was much as long as
Yeah.
just make sure it connects okay. Should update in a few seconds, but yeah. Okay. Yes. Good evening. Welcome to this talk. We will talk about LOLBAS, which is pretty much like a form of like binaries, EXEs, DLLs, libraries, and also scripts that can be used by the bad guys to harm us and pretty much use it to do whatever they want. So I'm here with my coworker and my friend Avneet. Let's do this. So the agenda for today, we got small introductions. We're gonna talk about some threat huntings and the tools that we mainly use, which is MITRE ATT&CK and what is TTPs. We're gonna talk about how ways of attackers, their perspective, what are the options they have when they are getting into the victims' environments, the pros and cons between each of them. I'm gonna talk about LOLBAS. We built a set of attacks from entering all the way to like exfiltration, using only LOLBAS, not only, using mainly LOLBAS. We're gonna have some small outro also. So, yeah, so we are not farmers, we are threat hunters for Bell Canada SOC. Our main function is threat hunting and threat intelligence. We do threat emulation and detection, which is trying the tools, trying the method that the attackers use in our system, and then we build detection on top of that. Yeah, it's pretty much like instead of building reports, we build detection compared to pen tester and stuff like that. Threat intelligence, we follow APTs that is targeting like telco, MSP and stuff. And we also build our ER rules, we deploy it, we create a pipeline to do like automated detection. Also tools development, we make tools just to help ourselves every day. Security trainings and presentation for all the other members of the SOC. Education, Avneet is coming from Montreal here, from Concordia University, Master of Engineering in the ISS also. I'm
alumni from this school, 2018. So disclaimer, this talk is not about farming. It's not about farming simulator, so don't sue us because of that. The opinions are ours. It doesn't represent anything related to my employer's view and his employer's view, which is the same. This presentation is for educational purpose only because we will be displaying like some script that is actually can be used for malicious things. And we are not responsible for any misuse of the information. So, before talking about all of us, I want to bring everyone here to threat hunting. And one of the biggest tools that we use as guidelines pretty much. So we're gonna try to categorize the attackers and the way they are doing things. There's already a framework. There's a lot of frameworks. I think some of you are familiar with like CKC, Cyber Kill Chain, Sticks, and Taxi. It's especially for for threat intelligence. And for us, the threat hunters, we have MITRE ATT&CK, which is knowledge-based adversary information of tactics and techniques. It's based on the real world, so it's changing. Like they updated the contents. Let's say if we see the use of PowerShell is lower, it will change on the documentation also. And it's open source, so any company can give their opinion. They can provide the MITRE with information, data. It created on September 2013. They have their own conference. It just happened a few weeks ago. And the main function of these tools is to track adversary, APTs, malwares, all the other bad guys, and to share this knowledge with a common language that us defender can share and can use every day. So there's three metrics. So pre-attack is anything before the attack. So it's like scoping, building infrastructure for the bad guys. The enterprise, so it's pretty much where the main attack, this is start from like initial access, so phishing and everything all the way to the extraction. This cover operating system, computers, servers, Windows, macOS, Linux, and also cloud. They just released it during the second conference a few weeks ago. So they cover also AWS all the way to like SAS stuff. And also for mobile, they also have index for Android and iOS. So we're going to talk specifically about the enterprise tactics because, well, for us, it's the most important one. So there's 12 enterprise tactics, start from initial access, when adversary trying to get in, execution, execute code, persistence, prefer escalation, defensive evasion, credential access, discovery, lateral movement, collection, command and control, exfiltration, and impact. So yeah, so all the attacks, they try to fit it in here. So let's say for like ransomware, it should fall under impact because that's impacting your company. They take away your data unless you pay something. Like Nmap scan and stuff like that. It's gonna go to discovery, credential access, Kerberos roasting, stealing hashes will go down there. So what are TTPs? So under each techniques, there's like something more, like the smaller item, which is TTPs, which is techniques and procedures used by the adversary. So it's they're pretty much the way they're doing the attack. So the thing about TTP is it's really hard to build detection on. It's also really hard for the adversary to change. Let's say the blue team detect the TTPs, so it's hard for them to change. All they need to do is the only thing available is to change TTPs to be undetected. So you can see there's like hash, IP address. It's pretty easy to change. You just spin up new like AWS or like DigitalOcean machine. Hash value, just change one bit and then it's completely new. Domain names, network artifacts, tools. Well, you might need to change some stuff like modify the code of your tools, but TTPs you cannot really modify it. So the pyramid of pain is actually used to describe how useful is the intel here. The intel here, it's like the log data that or like security logs, all the security reportings that Blue Team got. The difficulty of obtaining the intel, and also resource needed by the attacker to change. So, for example, for tools, you need to change the code, so it's more complicated than changing the hash value. So up to date, we have 266 enterprise TTPs. So that's are the ways of doing things from the bad guys' perspective. But that's not covering everything the bad guys doing. There's some stuff might not really important, so they didn't include it like in here. So it's like OWASP. They have like top 10, but there's like like a gazillion more. So in the TTPs itself, this is like the screenshot taken from their page. So they get the ID, they get the tactics. So one TTP can fall to multiple tactics. For example, here, the COM and DCOM TTPs, they can fall to lateral movement and execution. So you can use this COM, which is like a components and window, to do lateral movement. You can move like to different machine, and also to do some execution. You can execute your code. Yeah, so there's also like platform in Windows, Mac OS, Android. Permission required. Do you need to be system? Do you need to be admin? Data sources. So this is like for the blue teams. How do you detect stuff? And like support remote. Like can you do it like over the network? Yes or no? And there's also Navigator Enterprise. So it's just to navigate all the information. The 266. It's easier to see using this Navigator. Why do we need it? Because it's simple, it's easy to look at. It's pretty much like a JSON file that you can modify and then you can spin up using their is it Python wrapper like the website thing?
I think so.
Yeah. So why do you need that? So you can show your for Blue Team, you can show your managers, your management. We covered this much. We made progress over the years, so you get budget still. For tools for EDR. They actually do like a scoring for EDR. So if you don't score really good in this Navigator Enterprise, so you probably they're gonna buy another company's product. So red blue team planning. So you can see for red teams like, oh, I'm lacking in this section. I might develop some tools to do more of this section. For the blue team, let's say, oh, we covered this already. Like we need to move on to covering new stuff, or anything else you want to do with it. Like pie chart is not the best way to do it. Cannot really show everything. So this is the Navigator Enterprise. So this is all not really all. There's more down here. The 266 for the Enterprise. So you can see on the initial access, there's like hardware edition, plug in the USB, spear phishing, valid accounts, just log in using accounts, all the way to the impact. Data destruction, this content wipe. We see it on the wild. So this is pretty much the 266 ways that the enterprise user usually see. And for the usage, you can make something like this. So the green is like, oh, we get good coverage, we get rules, we get detection for that. For yellow, we get rules, but it's not really automated. We need to have like analysts to look at it, and also blue is like plan, and then white is like not covered yet. So yeah, so as an attackers, you actually have options, and you need to pick. Well, there's like 266 that we commonly see, but you cannot do all of them, right? Because there's not enough time, not enough resource, and also skill sets. Like building tools is hard. You can just take one from GitHub. Why would you build it, right? So attackers need to make decisions when they are performing an attack. So there's two attack avenues that we're gonna talk here. The first one is the fileless attack. So the main idea is you don't bring anything to the network. For examples, PowerShell. You might never use it, but yeah, they use it a lot in like real life. Every single APT setting they're using PowerShell because it's just there. For example, APT 2829, Cobalt Group, the malware Emotet, they use it for encoding, decoding, encryption, decryption, malicious macros. So, like for example, in our demo, we use malicious macros as the way inside the corporation. But the difference, we are using kind of like not fileless macro because we download file from the outside from our GitHub repo. So it's kind of slightly different. Use of WMI, which is like a tools Windows to manage your stuff used by the gang crab malware. Or the popular one is compile on the fly. So you just send the code on the memory, and then using the tools that's available on the server, you compile it. So there's like Python, there's like .NET, you can do C, you can do C++. Depends on the environment that you have. So what are the pros and cons? So this first one is simple. You don't need anything. It's already there, right? You just come in and then you use the stuff. It's stealthy. You don't create any file, you don't download any file. So the IDS, IPS, antivirus, they just like quiet. The cons is like, it's limited. You can do everything. And also it's specific target only, because you cannot use PowerShell in Linux because it's not there. The second avenue is the file drop attack. You'll bring everything to the network, all your tools and all the supporting binaries, all the config files. So, for example, there's two malware used by APT29, Cosmic Duke and Cosmic Car. So this is complicated malware. There's like a lot of codes inside, but they don't load it as a PDF file. They put it inside a folder and then start doing stuff. Mimikatz, if you're a pen tester, you use it a lot. If you're red teams, you use it a lot. If you're APTs, you use it a lot also. It's a tool built by actually red teamers researcher, and the APTs using it because it's so good. So what you can do with it, you can steal credentials, you can do, like you can submit hash, you can actually do curb roasting with it. So it's getting your way up to the domain admins, which is really important, like the end goal of like pen testing usually. And the last one is minor C. It's just your crypto mining malware. Pros and cons, it's unlimited. You can do whatever you want, right? It's your code. You can do whatever you want up to your skill sets. You can do any targets. You can make one tools that can attack Linux, Windows, Mac OS, whatever. The cons, you need to be sophisticated. You need money, you need time, you need power, you need skill sets. It's stealthy? No, it's not stealthy. You will create file, you will download file. So IDS, IPS, EDR, they're just gonna trigger like crazy. And also, yeah, antivirus also, like, although it's not really, like strong, but they still can detect some stuff. So, do we miss anything? Do you think we are missing anything, Abni?
Yes, the main subject of the presentation. So is it LOLBAS? Tas, do you think LOL stands for laughing out loud?
For the blue team, I don't think so, but for the APTs, yeah.
Yeah, so they laugh on the Microsoft, what they have done. So, okay, so LOLBAS actually stands for Living Off the Land Binaries and Scripts and the Libraries. So this term was coined by Christopher Campbell and Matthew Graber during DerbyCon 3.0, and it was previously known as LOLBeans, but now they have just changed into the LOLBAS. And now this project is being continued by Orevamo and other security researchers. And you can find this project from this GitHub link. And it's on official repository of Orevamo. So what actually LOLBAS is? So whenever we install any operating system, then OS just install a lot of executable libraries and other scripts that are being used by the components of the operating systems. So same is true with the Microsoft operating system as well. So whenever we install the Windows, then in the installation directory, we get a lot of executables, a lot of DLLs, a lot of scripts that are being signed by Microsoft. And sometimes those scripts, those executables have some functions that are undocumented. So LOLBAS actually means this is a technique that abuses the legitimate pre-installed Windows binaries to perform unexpected activities that will benefit malicious actors or red teams. Now there are some criteria for a binary or for a DLL or script to be categorized as a LOLBAS. Not everything is LOLBAS. For example, PowerShell. If you execute code by using the PowerShell, then it's not a LOLBAS because it's designed to do so. So to qualify a binary or a particular script to be as a LOLBAS, it has to follow these criteria. First of all, it should be signed by Microsoft, and then it should have an extra unexpected functionality that it is not intended to do so, and then that functionality would be useful for an APT and a red team. So there we can categorize lol bars depending on tactics that they're doing, that they fall under. For example, code execution. Here the example is hh.exe. This is a kind of binary that can execute a code from HTML. It's HTML, right?
HTML code.
HTML file, yeah. So this one can execute code from an HTML file, and then there is another one, code compilation using MS Build. You don't have to drop any executable into the target network. Just bring your code, use msbuild.exe, compile it on the fly, and just boom, go. And the good thing is, AV will not be able to detect this one, because a lot of AVs, they don't scan memory. They just scan the things that are present on the disk. And then you can download, upload, and copy the files using bitsadmin. And yes, so if you look at this image, and you see if any analyst is on duty and he sees a registry editor is being run on a server, then he might think that, okay, it's doing something, sysadmin is doing something with the registries. And if you take a closer and closer look, then you find it a bit suspicious, but at the end you're like, oh, we are attacked by APT group. So these are the lol beans that APTs can use to establish persistence on your system, or maybe to inject code in ADS, alternate data stream, that they can just use afterwards. And then they can use event viewer. The event viewer is the program that can be used to view the logs on the system. We can use event viewer to escalate the privileges. You can get system level access if you escalate the privilege using the event viewer. And then you can steal the credentials using findstr. It's a find string executable. So what you can do, you can just look for keyword password in the config files on a system. And then if you're lucky enough, then you can get a lot of passwords depending upon the type of server you're attacking. And then you can actually dump the process memory using com svsc.exe. And the main advantage of dumping a process memory is actually to get the secrets out of the process memory, like secret keys, your private keys, and the passwords, and some other cool stuff. And also, if you have a DLL, or maybe if you want to use the DLL that's already present on the system, then you can use run DLL32 or xsurf32 to execute your code. And lol bars can also be categorized by the type of file. For example, there are some binaries that are lol bars, some DLL are lol bars, and other MS binaries. Those binaries are not pre-installed by Microsoft, but they come with other Microsoft products like MS Office, MS SQL binaries, and so on. And some scripts like VBS, PowerShell script that are also lol bars. So, Tas, I have a question for you.
Yeah.
Do you know why attackers love lol bars more than their girlfriend?
Maybe because they don't have girlfriend.
Yeah, that's the right answer.
I don't know.
Okay, so why attackers love lol bars? So, first of all, it's off the LAN, so they don't have to drop anything. They can just use whatever is present on the system. And then you can do a lot of stuff, like from execution to exfiltrate the data, all the way to exfiltrate data. So you can escalate your privileges, you can just run random commands, you can just do encoding, decoding, and whatever you want. And all that's signed by Microsoft. And then, last but not the least, is often whitelisted by Blue Team. So there are very less chances of being detected if you use lol bars. So there are some examples of lol bars being used in real life. For example, APT29, which is infamous APT group known to disrupt US elections. And it has used run DLL32 to run their stage 1 payload, which in turn downloaded stage 2, stage 3, and so on. And then there is a Murray-Water that used MSHTA to execute the VBS script, and then did some malicious stuff along the chain. And so it's a time for demo. Did you pray to the demo god?
I forget.
Okay.
I forget.
Let's see how it goes.
Well, it's a video actually, so we don't have to pray. and before a video failed. Oh my god. All right. So before we go to the demo, let's see the flow of the attack. It's kind of fun, you know, like the usual stuff. Spare phishing email attachment. Victim download the malicious email attachment. They open it, of course, because they download it. They run the macro because the file tell them run the macro. The VBS launch PowerShell process. PowerShell download the payload from our GitHub. PowerShell execute the payload, and then the script do its job. It's pretty much scraping credentials, scraping information. It's pretty much like a data collection script, and then the script proceed to write all the data that they find into a temp folder, and then they encoded the data using the cert util base64. Nice. And then when needed, they can ship the data to C2 anytime. So just so let's map it to the TTPs, the tactics that the MITRE attack TTPs. Initial access, spear phishing, using VBS macro. Execution, PowerShell. There's two TTPs, scripting and PowerShell. Discovery, using rec.esc, schedule tasks, WMIC. Those are low bus. So we discover the account, file and directory, we query registry, get information. We find the system owner and user information. We do defensivation and also command and control using the cert util. We do persistent and also privilege escalation using valid accounts by using cmbkey.exe, which is also low bus. So demo time. The video, it's here. So yeah. So Avneet and me probably will be speaking through the video. Go ahead, Avneet.
So yeah, so you see initially there is no process running. So and if you look for the file in temporary folder named test, it's not present. And if you look for encoded file name, it's not present either. So what happened in this scenario is Suzanne from accounting, she got an email saying that there is a salary raise, and see what she did. She just downloaded the document file and opened it.
Yeah. I made the Word document, by the way. I want
So, yeah.
to put it up.
So you see, here just WinWord is running, so there is no child process of this WinWord, and it says to view the document, click enable content, and the moment she does that, you see WinWord spawns the PowerShell, and now the PowerShell has downloaded a script from the GitHub, and it is in the memory. Nothing is dropped on the disk, and it's executing the script in the memory. And then once everything is done, now what PowerShell gonna do? It's gonna exit and write everything into the temporary folder. So let's go and check what's there. So here we go. We got the file test.exe. So you see all the information about the host and other fancy stuff, and information regarding the privileges that a user has, which is currently logged in user, and name of all the user account present. This is IP root table, and then open network connections, and all the way to the credentials that we have stolen from the system. So once we have this information, we can actually exfiltrate as it is, but there are more chances to get caught. Then the good way is to encode this information. You can use the simple PowerShell module base64 to encode into base64, but we use cert util. The main advantage of using cert util is it converts everything that looks like a digital signature file.
Yeah.
So you see,
And also,
it starts with, yes, sorry, go ahead.
and also for that, like PowerShell, it's heavily monitored by a SOC. It should be.
Yeah.
Sometimes I forget about cert util because who knows, like literally XC can do decode and encode, right? So yeah, just want to add that.
So we have the file here. Now attacker can exfiltrate anytime he wants.
Just that. So So yeah, demo is finished. So let's look at the code, the PS1 code that we have. So yeah, I'm not gonna walk them through it.
Yeah. So this is.
Oh my god. Sorry. Should cancel it. Okay, kill it. Still?
Yep, still.
Alright, there we go.
So this is the PowerShell code that we use, and it's on the GitHub. So we are running few commands like system info, WMI, QFE, and then getting the child item of environment variables and so on, and all the way down to netsh dump, which is firewall rules, and then CMD is to get to just harvest the credentials on the system.
Yeah. Alright, so we did that. There's some VBS script. It's pretty much just using VBS calling the PS1 script.
Yeah,
and
so
then we show the encoded report and everything. So I think that's pretty much good.
So yeah, what VBS is doing, sorry to interrupt. So what VBS is doing, VBS itself doesn't contain any code. What we did, we just modified the author field from the document properties, and we injected a encoder PowerShell payload into that. And then once the victim opens the Word document, what VBS gonna do? It's gonna read the author field, and then it's gonna create a new shell, so which is a PowerShell. I mean the shell for the PowerShell, and then it's gonna run the encoded command into that shell, so which gonna do everything like whatever the script is doing.
So yeah, so hopefully everyone enjoy the demo. So we're pretty much at the end of the presentation. The next few minutes we're gonna spend on just a quick recap and also some Q&A. Recap about OLBAS. It's a technique that abuses legitimate Microsoft binaries, script, and other stuff to perform unexpected activities that will benefit the malicious actors. Follow certain criteria, follow certain file types. The benefit, it's off the line, multi-functions, it's signed, and also often whitelisted by the security team. So before the question, I wrote some FAQ. So if you want to see the slide deck, you can scan the barcode. Hopefully it's not that thing. Are we hiring for co-op? Yes, we do. Are you guys hiring for new grads? Yes. Can you buy you beers? Sure. So yeah, except him, striping. Yeah. Is there any question or anything?
Yeah. I didn't quite catch it. Did you say that like MITRE currently has a big enumeration of a lot of these
Yes.
LBASs? So
Yes.
I could like go through them.
Oh, that's not MITRE, the LBAS. I can actually show it to you. It's a GitHub page.
Oh yeah. So okay. So then in that GitHub page, so I started. Is there a list in there of all the like,
Yes.
binaries that are
So-
potential?
Categorized by type.
Cool.
Not this one. Which one is it?
Should be on whatever moves. Yeah, should be. Yeah, just click on the link.
This, it's quite fancy. They have like search. You can do like what you want execution.
If you want
So-
to get the execution.
So let's say you use like hh.exe too much. Like I want to use app.exe this time for like pentester or red teamers. So it's really cool. Yeah. So if there's no question, is there any more question? Yeah.
Yeah, so just the one thing when you were talking about the MITRE attack framework, you guys use it all the time
Yes.
in your SOC, I assume.
I forget to say something. It's used a lot by other companies. A lot of in US banks, finance, army. I think they use it also. They have presenters from everywhere, like Deloitte, at least the Dutch Deloitte and the Argentinian Deloitte. If you go to LinkedIn, you just type attack, and then you'll see like jobs they're using that. So they're using it pretty much, right? Yeah. So is that?
And then,
Okay.
the follow-up to that is, so I know like one big problem with MITRE is that some techniques are like very broad, and then some techniques are very, very specific.
Very specific. Yeah.
When you're, how do you like combat that? And when you have a technique that's very very broad, like execution
PowerShell.
or scripting or something.
Yeah, like PowerShell.
PowerShell, because you can do PowerShell for all the tactics actually, but they put it under execution. So, yeah, you can answer that.
Yeah, so if you see that there is a technique that's really broad, like PowerShell, so you cannot achieve 100% detection on that for sure. What you can do, you can just enumerate the attack framework and see, for example, defense evasion using PowerShell. If someone is running registry modification command using the PowerShell commandlets, then you can just detect that instead of just relying on regedit, execution of regedit, because PowerShell has their own module that you can use to change the registry, right? So what you can do, you can monitor for, the event logs for the PowerShell. That's 4104, I guess, right?
Yeah.
So that's what you can do, but for sure you cannot get the 100% detection on the technique. That's really broader.
Yeah. So I'm gonna add to that. So first of all, there's no way you get 100%. As a security person, there's no such thing as security. And then from like our story, like we actually do like everything first, and then we go deep. At some point, for example, MSSG or EXE, this thing can only do. It has its own TTP, but like we know it just can download and execute. Is there any other way they can do like stuff? Not really. So you can kind of check it like 95%, and then you just like, okay, it's not possible. And then also like for big companies, that's why we employ threat hunters. We just go out there looking for information. Is there new ways for people to do it? Is there like researchers doing it? Is there APTs doing it? So when we find it, so we get like, we hum, and then at the end of the day, we just linked it back to the TTPs. We can have like one TTPs with like one rule and ones with like 20 plus.
Yeah.
So you have to play with it. So yeah, that's one way I think you can differentiate how you treat different like a big yeah.
In your demo, was PowerShell the main exe binary that was being used, or were there other exes like deployed in the scripts?
Okay. Yeah. So you want to talk about it?
Yeah, I can just take it.
Okay.
Okay. So
to this slide. This stuff you use there.
yeah. So in this demo, the PowerShell was downloading a PS1 file from the GitHub repository, and this is a kind of fileless attack because it doesn't touch the disk; it's all in memory. And that PS1 script has a lot of commands, so which are like I can just show you. Okay, like this ipconfig/all. So it is using the Windows binaries to collect the information, and then at the end, so it's not here, but it's in the encoded PowerShell that you see the encoded big block of encoded data. So we are using certutil as well to encode everything instead of using PowerShell base64 encoder. So yeah, there are other binaries as well.
So we use probably like around 10 or to 15 binaries, and then some of them like 5 lolbas, and some of them it's technically kind of like lolbas, but because they don't fit the criteria, they just say like, no, this is not lolbas, even though they're giving information to attackers. So yes, there's definitely more, but the boat, it's PowerShell, so it's everything launched from the PowerShell.
I have a question. When you guys are doing threat hunting, are you guys given a specific question or a specific scope, or do you kind of just look at the data and see where it takes you?
When we are doing threat hunting, we go to Twitter. Yeah.
Okay.
But mostly, yeah. Like I have just a Twitter account with like 1,000 following, just all the people's doing research and everything. That's mainly the resource, but we also do like some hypothesis. We make our own hypothesis. Let's say the server is the admin just wanna install this application, and then is there like DLLs that can be hijacked? Is there like exe just like acting like lolbas? And then we try it, like we do that, we install the stuff. Also we go to GitHub a lot, like a lot of security tools. I just done presentation about not PowerShell. There's like 5 tools, kind of like PowerShell but not PowerShell. So we just look into it, we use it, we try to use all the functions, and yeah, like we look into our logs, we look into our detection. Is there anything triggering? Can we build alert on top of this? And then like if you say yes, okay, we build detection. That's a good day in the office. But if not, like, well, we try to find a way to do better, right?
Can I add something here?
For sure.
We spend a lot of time in the lab as well. So, I mean, so we can say that 40 to 50% of time is like researching in the lab, what's going on with the binary, and then we look into the logs, and then we see if the same behavior is also present in the network or not. So this is how this cycle goes on.
Okay. And also on the GitHub, on the blue team side, they have something called Sigma. So it's like a sharing platform of like rules and everything. So there's like APTs launching new malware, and then they just like, oh, this is the rule for that, and it's free. And there's also like the paid version of it, but the free one is actually pretty good for covering like the easy stuff.
Okay.
Yeah.
Okay. Thank you.
Yeah.
Yep. Okay. Let's give her. Are there any more questions? No.
No.
Please give her a round of applause to Taz and
Everyone. If you want to see more stuff from our team, we got a Medium page. Doesn't have a lot there, but we'll try to post more. Our Twitter, you can contact us on Twitter.
Cool.
Yep.
Yeah. Thank you.
Alright.
Thank you. And so, thank you guys for. Almost forgot. Thank you guys for showing up again. So a few of us are heading over to pub across the street. So if you guys want to show up, feel free to. There's usually a good turnout. Yeah, that's it. Thanks.
Thanks, guys.